Every country in the world is facing one or more than one form of undernutrition in their population. Women, infants, and children are particularly vulnerable to undernutrition. The latest data from WHO, in 2020, globally, we still have over 150 million children under 5 are stunting. This means their development in height are much lower than where they should be. This could have severe impact on their later life development. My name is Sheng Qi, so I work at the School of Pharmacy at the University of East Anglia. I'm a pharmaceutical scientist. I'm very passionate about developing technology and translating technology which can meet the unmet need clinically for patients. In September 2019, my colleagues and I were lucky enough to secure a Global Challenges Research Fund translational project, GRTA for short. The overall project is called Meeting the Sustainable Development Goals, and my own sub-project is centered on tackling child malnutrition. This project is focused on developing affordable and tailored for children supplements to tackle child malnutrition issues. Once we identify the region within the world are in need of such low-cost, affordable children nutritional supplements, we were out looking for partners. And what I realized is actually many of my past PhD students are scattered within this region. As an example, Champ graduated with his PhD a few years ago. He returned to his homeland, Thailand. And Champ now is working as a lecturer in Chiang Mai University. Sam graduated with her PhD many years ago. Sam came to UK for her PhD with her government scholarship. Once she finished her PhD, she returned to Malaysia to carry out being a leading scientist there. Also working on the project is Sam's colleague, Gita, whose research is mainly focused on the identification of childhood nutrition and the impacts of undernourishment on childhood development. In Jordan, we have Lorena and Alberto. They both were PhD students when I was lecturing at the start of my career. And they are now working in Jordan as a leading academic scientist, and they're working very closely with the regional pharmaceutical industry.
This product is planned to being developed by electrospinning, a rather new technology in the local pharmaceutical industry. At least we have very less, products has been commercialized on using this technique. And how is it going to make a difference? Because we are planning to actually develop a formula which is instantly dissolvable in the oral cavity. Okay, so hopefully it can solve the problem of difficulty in swallowing among the children or even among the geriatric. So how is it making a difference? We will adopt a very new manufacturing methods, and that particular dosage form can actually be applied to any other pharmaceutical active. So we hope that this has been a prototype for us. Okay, especially as a supplement, but it can actually bring and to actually develop some others formula, like even some active drugs and things like that, and that will truly make a difference in the pharmaceutical industry itself and to our local community, because this is a supplement. We hope that it can solve or at least assist the problem of malnutrition among the indigenous community. And this is where we are actually aiming to use the local ingredient, which is palm oil, which is rich in vitamin A, as our main ingredients for our product developments.
I think they're gonna like this project because of after we finish this project, we will organize a workshop to do the technology transfer, like how to make the gummy and all the recipes. So we train them how to make the gummy, and then after that, so they can try to change their recipe to make their own recipe. Like for our project, it can be just the prototype, and then they can change, they can alter to make their own recipe of the gummy by using their local source, like the juice, or maybe using the honey instead of the sugar syrup.
Actually, when we started the project, we had certain priorities that we wanted to fulfill. First of all, we wanted to create a product that was attractive for children. At the same time, it had to be easy to be manufactured and to scale up. So what it means, not only easy to be produced in the small scale, but also at industrial scale. And you must plan this from the beginning of the formulation. Also, we want the materials to be ideally locally sourced, so in Jordan. The manufacturing should be in a company in Jordan, and also the product should be inexpensive. So we had many priorities that we had to fulfill, and it was quite difficult to find a dosage form that will fulfill all these priorities. So for example, just to give you an idea, we started to think about gummies because they're very attractive for children, but then we found no company in Jordan that could produce using GMP the product in Jordan. Also, we didn't have locally sourced materials. The process of producing gummies is quite expensive, so that was a dead end for us. Although we wanted to produce gummies, we couldn't. So in the end, we found that the best compromise we can say that we could find was the chewable tablets. Why? Because somehow we are ticking all the boxes in the sense that they are still very attractive for children, inexpensive. Us as a researcher, we have a lot of experience with tablets, so we can really put our technical experience in the process. It is relatively simple to scale up, and we have a local manufacturer that can produce our tablets. So in the end, we went for chewable tablets as a type of dosage form.
The dream outcome of this project for me would be the formulation and the technology we developed through this project can soon be seen in the market as a real product and reach the children who are needing them. Also, on a personal level, I really hope the researcher and the scientists who are involved in this project can take away the skills they developed through this project in terms of translating science and technology into real-life product.